Today, we're tackling artificial general intelligence, AGI,
It's a huge topic.
definitely. And you're here because, well, you're curious. You want to get what it is, what's happening, what it all means, but without drowning in technical stuff.
And that's exactly what we're aiming for. We've synthesized a whole range of material for this.
Yeah, theoretical papers, discussions on different AGI approaches, the works.
Right. So our mission today is basically to unpack the core ideas, the big challenges, and the different paths researchers are exploring in this quest for AGI.
Okay, let's jump right in then. When we talk about intelligence here, what are we really getting at? And how is AGI different from the AI we already use every day?
Well, the basic dictionary definitions talk about, the capacity to acquire and apply knowledge.
Or the faculty of thought and reason.
Exactly. But the key difference with general intelligence is that it applies across a whole lot of different areas, different domains.
Unlike the AI in your phone or whatever, which is really good at maybe one thing.
Precisely. That's narrow AI. Fantastic at specific tasks, translations, recommendations, playing chess. AGI is meant to be more like us, flexible across many different kinds of problems.
So narrow AI is the specialist, AGI is the generalist.
Good analogy.
Yeah.
And figuring out what that general capability really means, well, that's where it starts to get tricky.
Because different fields see it differently.
Totally. A psychologist might focus on learning, problem solving. An AI researcher might think more computationally.
And control engineers.
They might see it as adapting to achieve goals in a complex world. It depends on your starting point.
We came across Pei Wang's definition too, which seemed important. It brought in limitations.
Yes, Wang's perspective is really crucial, I think. He emphasizes that real intelligence has to deal with insufficient knowledge and resources. Limited time, limited processing power.
Which is how the real world works.
Exactly. It's not about finding the absolute perfect answer if that takes forever. It's about finding a good enough answer now with what you've got.
And that contrasts sharply with some purely theoretical models.
Right, like Marcus Hutter's AIXI. Theoretically amazing, it can solve anything computable.
But assumes infinite computing power.
Which Wang would say isn't really intelligence in a practical sense. Maybe operating despite those limitations is the core of intelligence.
So the definition itself pushes you towards certain kinds of research. Do you aim for theoretical perfection or real-world effectiveness?
That's a huge fork in the road. And connects to another big debate. What are we actually trying to build? Something that thinks like a human brain.
Or just something that can do what humans do performance-wise?
Exactly. Simulating the brain seems logical, right? It's our one example of general intelligence.
But it's incredibly complex.
Mind-bogglingly so. And we don't even fully understand it. Plus, even a perfect simulation. Is it AI or is it computational neuroscience? A tool for studying the brain, maybe not an independent intelligence.
So a digital brain might not be the AGI we usually imagine, something that could solve problems in perhaps totally non-human ways.
It might not be. The other path is focusing on behavior. Can it act intelligently?
Like the Turing test.
The classic example. Can it fool you into thinking it's human in a conversation?
But just mimicking conversation, is that enough?
That's the counter-argument. Some say truly understanding human conversation requires more than just algorithms. It might need something like, human experience, embodiment, shared context.
Wow, okay. So maybe you can't just program understanding. It has to be grounded in some kind of experience.
It's a deep question. Does intelligence need a body, or at least a rich interaction with an environment?
All right, so we've got these different takes on what intelligence is, what the goal is. How are people actually trying to build AGI? What are the main strategies?
It's a real spectrum of approaches. One idea is sort of bottom-up, solve enough narrow AI problems, vision, language, reasoning, and maybe AGI emerges.
Just bolt them together.
Well, many researchers are skeptical about that. A component designed for a narrow task might need to be fundamentally different to work inside an integrated AGI. It's not just plug and play.
Right, like assembling car parts won't give you an airplane. The overall design matters.
Exactly. So a lot of focus is on integrative approaches, trying to combine ideas from different AI paradigms into a single, unified system.
But that integration is the hard part, finding a common framework.
Super hard. You can't just glue modules together if they, represent knowledge differently or reason in incompatible ways. It often means kind of reinventing things to fit the new architecture.
Like the Novamente project we looked at.
That's a prime example of trying to build a unified integrated system from the ground up. Then you have logic-based systems.
Using formal logic for reasoning.
Yeah. Different types, though. Some use term logic, like NARS or Novamente. Others use predicate logic, more common in standard computer science. They also differ in handling uncertainty.
Not just true-false.
Right. Things like fuzzy logic, degrees of truth, probabilistic logic. NARS has its own system for uncertainty, too,
Yeah.
like saying pretty likely or based on weak evidence.
And then there are the approaches trying to copy nature, biology inspired.
Definitely a major thread. Folks like Owen Holland, sometimes referred to as Grand, looked at creating artificial creatures with specialized brain-like lobes for different functions.
Simulating evolution or brain structures.
Kind of. And Peter Voss's A2I2 architecture is another interesting one. It's a neural network approach, but it pulls ideas from reinforcement learning, cognitive psychology, trying to capture the principles of brain function, not necessarily replicate the wetware.
And Voss focuses on virtual environments, right? Unlike others who stress physical bodies.
That's a key split. Voss believes you can get the necessary learning through rich virtual interaction, virtual embodiment.
While others, like Rodney Brooks back in the day with subsumption robotics.
Exactly. Brooks argued strongly that intelligence emerges from interacting with the physical world, that having a body isn't optional, it's fundamental.
So is intelligence internal computation or external interaction? Still debated.
Absolutely. And it's not just about single agents anymore. There's growing interest in the social aspect.
Intelligence arising from interaction between agents.
Yeah. The idea that mind isn't just inside one head, but distributed across a system, maybe even a culture. So you see approaches where multiple AGIs interact, or systems designed to be inherently social from the start.
Like Novamente, which has interagent communication built in.
Right. And finally, there's the animat approach from artificial life research.
Autonomous agents learning in their environment.
Yep, embodied agents, often simulated, sometimes robotic, learning through experience, development, interaction, really emphasizes the interplay between the agent, its form, and its world.
Wow, okay. It's a really diverse landscape. Let's dive deeper into Novamente since our sources detailed it. Why is it considered a significant integrative approach?
Novamente is presented as this really ambitious attempt to build a whole AGI system by integrating lots of different AI techniques. Its potential applications are things like knowledge management, data analysis.
So practical uses too. What's the core architecture like?
At its heart is a unified knowledge representation, a hypergraph of atoms. Think of atoms as nodes for concepts and links for relationships between them.
Like a big network of ideas.
Kind of, yeah. And importantly, these atoms have fuzzy truth values. So the system can represent uncertainty, like this is probably true, or this connection is somewhat strong.
Not just black and white.
Right. And this network is constantly being worked on by what they call the Mind OS layer, using specialized processes called mind agents. They analyze the atoms, infer new things, create new knowledge.
So it's dynamic.
Very. And knowledge isn't just in the individual atoms, there's also a map level. These maps are like fuzzy collections of atoms representing bigger things, concepts, schemas, events, even feelings or goals.
So atoms are the details, maps are the bigger picture.
That's a good way to put it. And there's constant feedback between them. Map patterns influence atom processing, atom changes reshape the maps.
And they see parallels to the brain.
They do draw analogies,
So let's talk-
lobes, neuronal groups, synapses, maps. But they're clear it's functional inspiration, not trying to build a literal neuron-by-neuron copy.
Capturing the principles, not the biology. How does a system like this handle real-world data, which is often, messy?
It's designed for diversity. Structured data from databases can map pretty directly to atoms. For unstructured text, they use statistical methods first. But the goal is deep understanding, turning text into meaningful semantic atoms and links.
So really understanding the meaning, not just keywords.
That's the aim. They also work on conversational querying, asking questions in normal language, and can learn. If an expert gives a query in natural language and formal logic, Novamente can learn to translate between them.
Clever. Learning the nuances that way. What about reasoning? How does it figure things out?
It uses something called probabilistic term logic. It's formal logic, but built to handle uncertainty with those truth values and confidence levels. It accumulates evidence, revises beliefs.
So it learns and updates its understanding as it gets more info.
Constantly. And memory is organized around concepts. Each known term has a concept holding related knowledge and tasks. Processing is highly parallel, drawing from the NARS system. New info can trigger cascades of inference, changing things non-locally.
A ripple effect through the knowledge network.
Exactly. And another key idea from NARS is functional autonomy. The system can generate its own internal goals, maybe tasks that weren't part of its original programming.
Leading to maybe creativity? or unexpected behavior?
Potentially, yes. It's not just following orders.
With all this going on, how does it focus? How does it manage attention?
It uses an importance value for each atom, based on things like recent utility with some decay over time. High importance atoms get processed, creates a sort of moving bubble of attention.
Focusing on what's currently most relevant and finding patterns, learning new things from data.
And as a whole toolkit, unsupervised methods like PCA, clustering, association rules like a priori for finding connections in big data sets, neural nets are in there too.
Standard machine learning tools.
Plus more advanced stuff like predicate learning using evolutionary programming, trying to evolve logical rules that are compact, frequent, clear. And it uses logic to check if patterns found in one data set show up elsewhere.
It sounds quite comprehensive. And language, you mentioned deep understanding.
Yeah, their NLP approach uses logical unification, integrating semantic meaning and pragmatic context for both understanding language and generating it. Adaptability is key for them. The system should learn new data types, new functions, without reprogramming.
Which feels essential for general intelligence.
Absolutely. Their philosophy is build the general foundations first, then higher cognition later. Learn from noisy, real data, often unsupervised. And it needs to act on the world, on its internal state, on its senses. Novamente has mechanisms for all three, including a system probe for metacognition, looking at its own processes.
Thinking about its own thinking.
Right. The big idea is synergy. General intelligence emerges from all these parts working together. They've built proofs of concept, like a site assistant that learns object names from voice commands.
It's definitely a very holistic vision for AGI, but as you said, there's still a lot of debate, even skepticism about AGI in general.
Oh, absolutely. It's not a universally accepted goal within AI. There's skepticism about feasibility, timelines, and a lot of focus on narrow AI, which is, commercially successful now.
And people worry about repeating past AI hype cycles.
That's part of it. Plus, fundamental disagreements about intelligence itself, often drawing from psychology or neuroscience.
Are there common mistakes or traps researchers fall into?
The sources point out a few, like getting bogged down in biological mimicry without grasping the underlying principles, or maybe rigidly insisting on physical embodiment when virtual learning might be sufficient for some aspects.
Or ignoring psychology.
Yes, a big one. Trying to build intelligence without understanding insights from cognitive psychology can lead you down blind alleys, like assuming intelligence just pops out of massive, meaningless data sets.
So understanding the what and why of intelligence is as vital as the how of coding.
Crucial. The argument is that focusing on general learning abilities, even though complex, is ultimately the path to more capable and maybe even less expensive AI in the long run.
Are there radically different approaches being tried too?
Yeah, things like evolvable hardware, the cam-brain machine idea, trying to evolve circuits directly, potentially much faster than software simulation.
Bypassing software bottlenecks.
Potentially. Then you get into more theoretical territory. Universal algorithmic intelligence, Solomonov's theory. The idea that the simplest explanation is best.
Which leads to things like a speed prior.
Right, maybe favoring the explanation that's fastest to compute, which might be more practical than the absolute simplest.
And self-improving AI models.
Like the theoretical Gödel machine, aiming for optimal self-improvement. Or the program search idea intelligence as finding the right program for a task, maybe with a search procedure that learns to get better at searching.
So many different angles. What about evolution as inspiration?
Big influence. Drawing parallels between biological cognitive evolution, how simple reflexes might have led to complex reasoning, and AI development. Concepts like functional systems from biology seem relevant. People use models to explore how adaptive or social behaviors might emerge evolutionarily.
And emotions, do they fit in?
Some researchers think so. Maybe emotions act as an internal grading system for an AI's simulations or choices. There's also the 3D simulation theory of cognition, that understanding comes from running internal simulations of the world.
The AI needs an internal world model.
Essentially. And ideas like colonic conflict resolution for symbol manipulation, layered architectures from code up to goals, lots of theoretical work. A key point made is the difference between brain hardware, massively parallel, and computer hardware, mostly serial, just very fast.
So AIs might have to be intelligent in a different way?
Possibly leveraging their speed differently, and maybe the secret isn't programming everything in, but knowing what not to program, creating the right conditions for intelligence to emerge.
Letting it learn and develop.
Concepts like reversible features, things that both detect and control features, seem important for concept learning and mental imagery, which acts like a workspace for thought. beliefs bridge concepts and thoughts, how goals break down into sub-goals and actions. It's all part of the puzzle.
It keeps coming back to modeling, predicting, adapting.
That seems core to generality.
Mm.
And then there's metacognition, again, an AI like ISA, modeling its own processes to improve itself.
But that feels like a chicken and egg problem, using weak AI to build stronger AI.
It is.
Yeah.
Which probably means initial progress will be on smaller, measurable improvements. And even the definition of success, human equivalent intelligence, means different things to AI researchers versus, say, evolutionary psychologists.
It really underscores the sheer complexity. We're talking about a vast, challenging field.
No doubt. The quest for AGI involves so many disciplines, so many different bets being placed, and so many fundamental questions still open.
So the big takeaway is, it's complicated. There's no single guaranteed path, but the field is buzzing with ideas.
Absolutely. Lots of research, lots of debate, lots of potential dead ends, but also lots of fascinating possibilities being explored.
So as you digest all of this, think about those different definitions of intelligence, the variety of strategies. It really makes you appreciate the scale of the challenge.
And maybe a final thought to leave you with. Given all these different perspectives, logic, biology, integration, evolution, computation, what element do you personally think will be the absolute key, the critical breakthrough needed for true AGI? And what kind of future might that particular breakthrough unlock?